Our next question is given that a truck is moving at 72 km per hour and carries a steel girder which runs on its wooden floor. What is the minimum time in which the truck has to stop without girder moving forward, and the coefficient of static friction between steel and wood is 0.5. So let's say this is the truck on which a steel girder is placed and the floor is wooden. So weight is acting vertically downwards, that is the normal. And the coefficient of friction between the steel, this is of steel, this is of wood. Coefficient of friction is given uh, 0.5, and the initial velocity of the truck is 72 km per hour. So 72 km per hour is equal to 72 into 5 by 18 meter per second. So 18 fours are 32. So this initial velocity has to be 3 meter per second. Now we have to stop. That is the final velocity is 0. And let's use this, the coefficient of static friction, which is equal to force of friction divided by the normal reaction, and force coefficient of friction is 0.5. Force has to be mass into acceleration. This is mass into g, this gets cancelled, and acceleration is 0.5 into 9.8 meter per second square. We have to find the time. So let's use the equation v is equal to u plus at. Final velocity is 0. Initial velocity, this is actually the retardation, so it has to be negative, and uh, acceleration, this is u. Initial velocity was 72, which is 20 meter per second. So this is 20 plus negative of 0.5 into 9.8 into t. So this is equal to negative 20 is equal to negative 0.5 into 9.8 into t. So negative negative gets cancelled. Time is equal to 20 upon 0.5 into 9.8, and this is equal to 400. So this is 40, and this is 400 by 98, which is 200 by 9. So if we divide 200 by 49, so 200 by 49 should give me the value 4 point. Okay, so this is to cancel it with 5. So this is 40, and 400 by, sorry, 200 by, it's 200 by 49. So if I divide 200 by 49, that should give me the value 4.08. So that is equal to 4.08 seconds is the answer. Thank you for watching.